Hey there, and welcome to The Explainer. This is where we take big, important ideas from some of the most influential sources out there, and well, we break them down.
Today, we are diving deep, right into Chapter 6 of Robert C. Martin's legendary book, Clean Code. We're going to tackle a concept that honestly separates the pros from the amateurs, the critical difference between objects and data structures.
All right, first up, let's talk about a problem. A trap, really, that every single one of us developers falls into. Doesn't matter if you're a junior or a senior architect, you know this feeling. It's this cycle we get stuck in, and it actually has a name.
Yeah, Uncle Bob calls it the primal conundrum. Think about it. We're under pressure, right? The deadline is looming, so we rush. We make a mess. But here's the kicker. That very mess is what ends up slowing us down, and we miss the deadline anyway. It's a super frustrating, vicious cycle.
So how do we break out of it? Well, the only way to really go fast is to go well. And a huge source of this messy slowdown, according to the book, comes from a really simple misunderstanding, a mix-up between two of the most basic building blocks in our code.
Okay, so that brings us right to the heart of this chapter. It's an idea Martin calls the data/object anti-symmetry. And trust me, it's a really powerful way to think about your code.
So the key here, and this is crucial, is to realize they're not just a little different. They are polar opposites. Like the quote says, objects are all about hiding their data behind these abstractions, right? They show you functions that work on that data. But data structures, they're the exact opposite. They just expose their data, wide open, and don't really have any meaningful functions. This isn't just a small detail, it changes everything about how your code can grow and adapt over time.
And this table here, it just lays it all out perfectly. Look at that opposition. But check out those last two rows, because that's where the magic is. With objects, it's super easy to add brand new types of things without messing with your existing code. But if you want to add a new behavior, a new function, you got to go and touch every single class. Now flip that for data structures. It's the complete opposite. Adding a new function is a piece of cake, but add a new data type, now you've got to go back and change every single one of your functions. See? Total anti-symmetry.
So you see, this isn't just some academic theory. It has massive implications for building systems that can actually change without breaking. The choice you make really boils down to one simple question you have to ask yourself about the future. What's more likely to change? Am I going to be adding new kinds of things? Or am I going to be adding new actions to the things I already have? That one question should guide your design.
All right, so this whole distinction, it leads us right into a really famous principle for good object-oriented design.
Yeah, the law of Demeter. Put simply, it's talk to your immediate friends, not to strangers. An object shouldn't be spilling its guts to the world through a bunch of getter methods. If you find yourself asking an object for another object, which you then ask for another object, you're probably breaking this law. You're not talking to your friend, you're talking to your friend's friend's cousin.
And when you violate this law, you often end up with something the book has a fantastic name for, a train wreck. And I promise, once you see it, you'll start seeing it everywhere.
This line of code right here, this is the textbook definition of a train wreck. Just look at that chain of calls. Get options, get scratcher, get absolute path component. It looks like a bunch of train cars all coupled together. And the problem is, your code now has to know way too much. It's coupled to the internal structure of CTX and options and scratcher. If any one of those three things changes its internal structure, poof, your code breaks. That is the very definition of fragile, tightly coupled code.
Now breaking up the chain, like we see here, okay, it's a little better. It's not one giant train wreck line. But look closely. It's still exposing the internal structure, right? You're still asking for data and navigating through it. The ideal object-oriented way is to tell, don't ask. Instead of digging for the info, you'd simply tell the CTXT object what you want to do and let it worry about the details internally.
So this is where the confusion can really bite you. Sometimes developers try to have it both ways, and they end up creating something that's honestly even worse than a train wreck. It's a huge red flag for a muddled design.
Yep, these are hybrids. The worst of both worlds. They try to do everything. They have functions that do important stuff, like an object, but they also expose all their internal variables, like a data structure. And what's the result? Well, you get all the drawbacks and none of the benefits. It's hard to add new functions, and it's hard to add new data types. It's the worst of both situations. Just avoid them.
Okay, so this might sound like I'm just bashing data structures, but I'm not. They absolutely have their place. So the question is, when are they the right tool for the job?
Well, one of the most common, most useful forms is the good old data transfer object, or DTO. Its job is simple.
hold data. That's it. It has zero behavior and it makes no apologies for having all its data public. Because, well, that's its entire purpose. It's just a messenger carrying a package of data from one place to another.
And a popular variation on this idea is the active record. If you've done any web development, you've definitely seen these. They're basically just data structures, but they often come with a few handy methods for database stuff, like save and find. They're direct representations of a database table.
So what's the solution here? How do you use these things cleanly? It's all about separation. You have to resist that temptation to cram all your complicated business logic, the rules about how your application works, into these active records. No, treat them as pure data containers. And then you create separate objects, real objects, that hold all those business rules. And those objects operate on the data that the active records carry around.
Really getting this distinction and knowing when to use which pattern, that's truly the mark of a professional developer.
And I love this quote. Mature programmers know that the idea that everything is an object is a myth. It's so true. It's not about being a purist or some kind of dogma. Sometimes you genuinely just want a simple bucket of data and some procedures that operate on it. It's about being pragmatic and choosing the right tool for the job you have right now.
So let's just bring this all home. This is the one thing to remember. Objects expose behavior and they hide data. Data structures expose data and they have no significant behavior. Choosing between these two consciously is one of the most critical design decisions you can make for the long-term health of your code.
And that's the whole point. Good developers, professional developers, they understand these trade-offs. They don't just follow some rule they read in a book blindly. They get the why behind it, and they choose the approach that actually fits the problem they're trying to solve.
So here's my challenge to you. The next time you're writing code or even looking at your existing code, ask yourself this question. Look at a class and ask, does this thing hide its data or does it expose it? And more importantly, why? Because making that choice on purpose instead of just by accident, well, that's the real foundation of clean, professional, and maintainable software design.